As we saw, there are many parameters that we can set for MLP classifier, and we can also combine, so there are many options that we can set them to, and we can also change multiple of these parameters at the same time. So we don't only have to set the activation, we could set the activation and the hidden layer sizes, for example, and the solvers. And there are many other parameters that we can also change, all of them with many options. And it isn't always feasible to do all of this manually, since there are many combinations of parameters that we set, of options for those parameters. So if we want to find the best solution, we won't do this manually, but we can let Python do it for us. One way to choose these parameters is to use cross-validation. That is, we take a subset of the training set that we use to validate the results that we get. That is, we use, for example, we take 9/10 of the training set for training, and then we see how and then we evaluate the classifier that we've trained using the remaining 1/10 or 10% of the training set. Then we can take another 10th of the training set for to use for validation, and the remaining 9/10 for training. And we can do this multiple times. So this thing that I just described is called cross-validation. That is, we split up the training set into some number of subsets, and then we use all but one for training and one of them for validation. And we do this for so that each subset gets to be the validation subset once. Right, so scikit-learn has functions that can do cross-validation automatically, so we don't need to program this. We can just use the built-in methods from scikit-learn. One of those methods is the grid search cross-validation, which is what we're going to use here to optimize the parameters of the MLP classifier. So this method can also apply to any other classifier used in scikit-learn, but here we're going to use it for the MLP classifier. So first we want to import this method. So this is in the model selection module. But we want to import grid search with cross-validation. So first we're going to define our MLP classifier. So this way we're just defining an MLP classifier that uses all the defaults for the parameters. And then we're going to define some parameters that we want to try out with different values. So we want to try out different values for the hidden layer sizes. So the options we're going to give as a list in which we're going to put everything that we want to try out. Let's try out the default with 100 neurons in one hidden layer. Then let's try having 3 hidden layers with 10, 50, and 10 neurons. And let's try, for example, one hidden layer with 20 neurons. Right, and maybe 2 layers with 100 neurons each. Then let's try different options for the activation function. So we're going to try out the sigmoid, hyperbolic tangent, and the rectified linear unit. Next we're going to try out different learning rates. So again, we're going to use the default of 0.001 and maybe some higher learning rate. And maybe let's try out different solvers. So let's try stochastic gradient descent solver and default atom solver. So these are the parameters that we want to tune in this example, but of course we could use fewer or more parameters in this dictionary. The next step here would be to evaluate this. So to evaluate MLP classifier with all of these options, so all combinations of these options, and to see which one works best. So we define a classifier using this method that we imported, or rather this this class that we imported, the grid search cross validation. And then we pass the so the classifier that we want to optimize. In this case, it's this multi-layer perceptron grid search that we defined. Then we pass in the parameters, so a dictionary of the parameters that we want to try out. And then we say how many, so what type of cross-validation we want to use, or how many subsets do we want to have during this cross-validation. So we're going to set 5 here. That means that the training set is going to be split up into 5 subsets. And then every time we're going to use 4 for training and 1 for validation. So we use, let's say, the first 4 subsets as a training set, and then we use the last subset as a validation set. So we see what's the accuracy if we train on the first 4 and test with this last subset. Then, for example, we could take the last 4 subsets, train on those, and then test using the first subset and see what the accuracy is there. And we do this until we've used all possible subsets as a validation set, and we take the average accuracy across all of these. That is gonna give us a fairly reliable indicator as to what the accuracy is for the given set of parameters. And it's not going to be influenced much by the random initialization of weights. So, okay, we're going to run this. Right, so we define this, and now again we just fit this classifier that we defined as usual on X and Y. Right, so now this is gonna take a while because again we want to try out many options, and we want to try out each combination of these options multiple times. So each of these should be done 5 times, as we said. So it's gonna take a while. We can see here the first training. So the first 3 times we trained, we came up short, that is, we didn't converge. So now we're just going to skip to the end because this is gonna take a while. We finished optimizing the parameters, so now we want to see what the best parameters were. So let's let's just take a look at them first. So we can access them using the best params. They're in the best params attribute of this class, of this object that we created. So let's see. We got the best results using the hyperbolic tangent with one hidden layer with 20 neurons, with a learning rate of 0.001 and the solver atom. So now we don't have to create a new MLP classifier where we set these parameters manually. This classifier that we created will actually just use those best parameters to compute, to use and classify the data. So we could just say we want to score. So we can just use this object here that we created for the grid search as a multi-layer perceptron classifier. So I want to see what the result would be if we have X test or Y test and this classifier that we created. So the accuracy, so here we can see the scores. So the accuracy is 95.59%, the precision 59.71, recall same as the accuracy, and the F1 score is 95.6. So while this looks like it's maybe slightly lower than some of the other examples we had, the difference here is only due to the random initialization differences. But on average, if we try this on different data or on a similar data set, but for example with different data, we would get better results using these parameters than the ones that we used here. So, for example, here when we use the hyperbolic tangent with 100 neurons in the hidden layer, we got results that look like they're slightly better, but on average we get better results using only 20 neurons in the hidden layer. I think that's the only difference from the defaults here. So using the hyperbolic tangent as an activation function, using 20 neurons in the hidden layer instead of 100. All of the other best parameters turned out to be the default ones. Right, so to conclude, we can use this grid search cross-validation in scikit-learn to find the best parameters for the multi-layer perceptron classifier.